Okay guys, hi, it's Mr. Jones. I'm giving you guys this video for two reasons. First of all, I'm not here today. And that's because I have been sick since Tuesday. So for most of my Thanksgiving break, I spent on the couch trying not to get my pregnant wife sick. And it was kind of a bummer. But anyways, I still want to teach you guys, but I think it's best that I'm not here for another day or two. So let's try and do it this way. Today's lesson is 5.2, Simplifying Expressions. And you guys can turn your books to page 252. Go ahead and put that there for you. 252. Okay, and really important lesson today, guys. This lesson is so important because it's basically the foundation. We've talked about foundations before, how it's the first part of the house you build. Well, this is the foundation of algebra. You guys know how to add and subtract positive and negative integers and all that good stuff. And now we're going to go on to variables and learn how to simplify expressions using variables. And I need you to do one thing. Don't be worried. Because it is easy once we learn our terms, our key terms, and we actually have a word in our key terms called term. So we'll learn what those are, and then we're going to be able to simplify these expressions like nobody's business. Okay? Let's start off with our key terms. So here in our key terms on the left side, can you see that okay? Yes. We have term, and a term is part of an expression that's added together. That's what your book says. And so you can see over here our first example. I have two parts of it. I have the really colorful one that connects to our colors in our key terms, and I have the plain Jane one here. But the terms are basically the pieces that are added together. Okay, the parts like this, because there's a plus sign separating it, the 4x, and then the plus 6. Those are all different terms. They're the pieces that are added or subtracted together. The next part's coefficient, and we kind of know this one already. Coefficient is the number in front of a variable. That's the 7th grader definition right there. It's not the book definition. In the book, well now, in the book they're going to tell us that it's a number multiplied by the variable. Okay, it's a number multiplied by the variable. And basically you can see that I have written down purple here. I don't know if you can show up on the camera or not, but it's purple here. And also our negative sign right there is purple as well. Okay, I did it for a reason, to show you guys those are coefficients. Now this one's easy to see. It's going to be 4 times x, and actually you might even say positive 4 times x. Okay, but you might say, wait, Mr. Jones, I don't see any kind of number multiplying the x. Well, it's kind of one of those invisible things we have in math. Like I've told you before, mathematicians they're not lazy. They try to be efficient. They try not to write too much. They try not to be too obvious. And so don't forget, there's always that little hidden 1 right there. Okay, it's multiplying this x. Our coefficient is -1. Whenever you see a negative sign in front of a variable, its coefficient is -1. Okay? Alright, next part is like terms. And like terms, if we have to go back and make sure we understand what terms are here. Terms are right here, again, the parts that are added up together. So here we have -x, we have positive 4x, and then we have plus 6. So these are our terms. Now the way we tell if two terms are like terms, or similar, or can be added together, these are all different ways you can say it, is you look at the variable. It's the only thing you look at, the variable. Okay, x's can add with x's. Alright? X's cannot add with y's. X's cannot add with constant terms. And yes, I said it. That's our next key term, is constant terms. And see here I've squiggled the blue line underneath it so you guys can see it match up over here. Our constant term is 6. And they call it a constant term because it never changes. It stays the same. Okay? We can't plug a number into it because it's not a variable. It's just a plain old plus 6. It does not change. Okay? So let's go over them one more time really quick. Term is the parts that are added together. So x, or -x, sorry, 4x and 6. Those are all 3 of our terms in this expression. We have coefficients, which is the number in front that multiplies the variable. We have like terms, which are numbers that have the same variable. We have constant terms, which are the numbers that are just basically whole numbers. whole numbers, integers, decimals, fractions, anything without a variable is our constant term. Okay? Alright, let's move on. Okay, here's example number 2, guys. Now the first one I did all by myself, so you guys could watch and see how it's done. This one I want us to do together, please. Okay, so I'm going to do it, but you're going to do it also in your notes, so you can have an example for your homework tonight, so you can see how it's done. Okay, the problem is this. The expression is this, excuse me. 5x plus 2 minus 7x minus 3. So our job right here is to identify. Do you guys see that word right there? Identify, which means to figure out which one is which. We're going to identify the terms, the coefficients, the like terms, and the constants. And the best way to do this, you guys, is to be a little bit organized. And it's sometimes hard for us to do. It's definitely hard for me to do sometimes. But if we can get organized, it'll make a nice answer here, and it'll help us to keep on track. So what I want you guys to do is I want you to put your answers out in rows like this right here. And so we're going to list our terms straight out in a line. And then our coefficients straight out in a line. Our like terms and our constants. Okay, we can keep them all separated like that, and we can tell what they are. Okay, so we may need to go back and use our definitions to figure out this problem exactly, how it should be done. Let's go ahead and give it a shot. So I'm going to give you guys just a second to maybe think about what your answer might start with, and then I'm going to go ahead and carry on so you guys can see. And also, this example is in your book on page 252. So I don't want you to use that just yet. Okay. Okay, so we've had enough time to think about it for a second, and here we go. So our terms. Our terms, what we said, are the parts that are added together in an expression. Now we have to remember, negative signs or subtraction signs basically mean that we're adding a negative. It goes way back to the second week of school. So really we're adding a negative here. So yes, these are all being added together. Our terms are 5x, comma, 2, comma, negative 7x, comma, negative 3. So if you can see right here, we have 1, 2, 3, 4 terms, and you can go back down and check right here. 1, 2, 3, 4 things being added together. Okay, next part, coefficients. Coefficients. Now I want you guys to do something real quick. I want you guys to ask your partner. One of you ask the other one to define or to explain what a coefficient is. Okay, go ahead and take a minute for that. In about 5 to 10 seconds. Go. Okay, that was 10 seconds. So you guys should have told your partner, or your partner should have told you, that a coefficient is the number in front of a variable. And if they were really good, they would have told you the number in front of the variable is doing something. It's multiplying the variable. Or another way you guys could say it is telling us how many there are. Okay? Like you could say here there are 5 x's. Okay. So coefficients. We have a coefficient here because there's a number in front of the variable. So our first coefficient is 5, comma. Now, is this plus 2 going to be a coefficient? Because there's no variable. And so if we go back to our definition, coefficients have to be a number in front of what? That's right, a variable. So 2 is not a coefficient. How about next one? Okay. 7. So our next coefficient is 7, right? Right? Not too fast. It's not just 7. We have to be careful. If there's a negative sign or a subtraction sign, we have to remember that's going to be a negative coefficient. A negative coefficient, or it could be a negative constant, like in the very end. Okay, so our next coefficient is negative 7. Negative 7. Have to include those negative signs. And then we can go to our last stop here, -3. Is there a variable? No. No variable. It's not a coefficient. Does not have a coefficient. Alright, next is like terms. And if you remember, like terms are terms that have the same, yes, variable. The same variable. So our like terms here are pretty easy to spot because we only have one kind of variable here and here. They both have x's. So our like terms includes the whole thing, coefficient and variable. Our like terms are 5x, comma, -7x. Very good. And then finally we have some constants we need to pull out of the expression. And we can see them pretty easily because they do not have a variable. Good job. So this one is going to be our first one. This one's not a constant. Why? Yeah, that's right, because it has a variable. This one is a constant because it does not have a variable. So 2, comma, and then -3. Don't forget those negative signs, people. Those little mistakes will get you on the test. Okay, the little mistakes kill sometimes. Be very careful. Double check stuff. So, we've satisfied the question. We've gone through and identified all of our terms. Our terms are basically the pieces that are added together. 5x, 2, -7x, and -3. Just like that up here. Coefficients are the numbers in front of the variables. Number here in front of the variable. Like terms, same variable. Constants are the numbers with no variable. So you guys did a good job with this one. Next, we're going to have you guys try a problem doing partner work only. Okay, so I'm not going to do this one for you yet. I'm going to have you guys do it two problems. Partner 1 is going to do the first problem, and partner 2 will do the second problem. Okay, I have set up your partner 1 and partner 2 problems. Partner 1, start off the explaining. Okay, so you guys know the drill. Partner 1, you're going to do the problem, and you're going to explain everything you do, and every reason why you picked certain things. You're going to explain this to your other partner. Okay, partner 2, you are listening. Okay, you're watching for mistakes. If they make a mistake, very kindly say, "Hey, I think you made a mistake." All right. And then finally, when partner 1 is finished explaining and partner 2 has checked it, partner 2 needs to copy down the problem and the answers that were given in your notes. And then the same thing for partner 2. Partner 2 explain. Partner 1 is listening, and checking. And then finally, partner 1 will copy. Okay? You guys will have about 2 minutes per problem, so that's 4 minutes, starting right now. Go. Okay, so here we go, guys. We're going to explain and make sure we have the same thing for both of our partner 1 and partner 2 problems. Here, partner 1, our terms are -4x, comma, -3, comma, 17, comma, -10x. See, little details matter. Our coefficients here. Coefficients are -4. -4, comma, no, yes, and -10. Okay, our like terms are going to be two different pairs. Our first Okay, here's our next set of examples, you guys. These are going to start off, I hope not to insult your intelligence, because the first one is like baby steps. Okay, here we are combining like terms, and don't make sure you know what the word combining means. Combining means to put together, right? Put into one group. All right, and you know how they say apples and oranges? Okay, sometimes you can't combine apples and oranges because they're different. Well, it's kind of the same thing here. We can only combine apples and apples, or we can combine oranges with other oranges. Let's see what we have here. Okay, example A. 3x plus 4x. Now, how do I know if these are apples and apples, or if they're apples and oranges? Well, it's because of their variable. If they are like terms, then you can add them or subtract them or whatever the operation is here. Okay, add or subtract. So, all you do to add 3x plus 4x is you add the coefficient. 3 plus 4 is 7. So this becomes 7x. How simple is that? Okay, very, very simple, I think. The next problem is a little more complicated, but still, I'd say on the very easy range. Okay, we have to know our stuff from example 2. What are like terms? Do I have any like terms? Sometimes it helps to, if you have a hard time, sometimes it helps to underline them or circle them or do something, let yourself know that they are like terms. Let's go ahead and put a little star by our terms that have a y in it, okay? A y. And then we have no other ones here. Okay, so we're going to be adding the negative 9y plus 7y. Alright, so our simple rules say add the coefficients. So negative 9 plus 7. So go back to our rules. Negative 9 plus 7. It's like we do our subtraction. 9 minus 7 is 2. Who's the boss? The 9 is bigger, so we keep its sign. So we get negative 2y. Okay, so from 9y, negative 9y, and 7y, we got negative 2y. Now, can I do anything with my z, 5z, and plus 2? Can I combine those two? Are they like terms? That's a question you'd ask yourself. They are not like terms, so you cannot combine them. They just come straight down to our answer. Plus 5z plus 2. Okay, let me write it down in black so it stands out. Final answer is negative 2y plus 5z plus 2. Stand out enough? I think so. Okay, we have our next part of the lesson, partner 2 and partner 1 problems. Partner 2 is going to start us off here right now. Partner 2, your problem says r plus 2s plus 3r. And then partner 1, yours says 11w plus 9z plus 3w minus 12z. So remember, you're going to combine like terms only. Like terms only. You can have about 2 minutes per problem. That's 4 minutes total. Remember to explain, 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 and then partner 1, you will listen, 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 and then finally copy, copy, copy. And then reverse it for partner 1's problem. Go for it. 2 minutes starting now. Okay, you guys had enough time to go for them. Let's still go ahead and make sure our answers are correct. Partner 2, you should have seen that we have an R here and 3 R's right there. So how many R's do I have here? It doesn't say. There's no visible coefficient, but we know there is a 1 right there, okay? Don't forget about the invisible coefficient. So 1 R plus 3 R's gives us 4 R's. Okay, so we have 4R now. And then the 2s does not have any like terms, so we just keep it down in our final answer, plus 2s. You should have 4r plus 2s, or you could have had 2s plus 4r. It doesn't matter because we're adding, and we have the commutative property of addition, which says the order you add does not matter. Now on to partner 1. Partner 1 is a little more challenging, but it came second, so you guys had more practice already. Partner 1, you need to look. We have 2 different kinds of variables here. we have 11w plus 9z plus 3w minus 12z. Okay, so let's do our w's first. If it helps you, you can draw a line to connect your w's. That way you can see it. Change colors here so it stands out a little better. Okay, 11w plus 3w. Now how do we do that again? Yes, we just add the coefficient. Add the coefficient. So positive 11 plus 3. Positive 11 plus 3. That's going to be 14w. So those two terms have been canceled, not canceled, they have been combined. So once we combine them, they're used up, right? Now they both of them exist right here in this little part of the problem now. They have been combined because they are like terms. Alrighty. Now we get to combine our z's, which might be a little trickier. Our z's, because it's negative 12z. Negative 12z. Now don't be freaked out by the negative signs. We have 9z plus negative 12z. 9z plus negative 12z. Now you guys might say, wait, Mr. Jones, how are you getting plus? It says subtract. It's because, you guys, we know from earlier in the year, when we have subtraction, we know it's the same thing as adding the negative. Okay, here it'd be the same thing as adding negative 12z. Okay, because we're smart, we can do that no problem. We know automatically, hey, let's just grab the whole thing and say it's gonna be negative 12z. We're gonna add them together. Okay. So 9z, and they're going to add negative 12z, 9 plus negative 12. Well, that's like saying 12 minus 9, and that's just going to be 3. And is it positive or negative? The 3 here is going to be positive 3 or negative 3. Well, we have to go back up and check our signs. I'm sorry. We have to go and check the coefficients. The coefficient, the 12 is larger than the 9, and it's negative, so it's going to be negative or minus 3z. Now that we've combined all of our terms, we are done with the problem. We have 14w minus 3z. Or the other way you could have written it would be negative 3z plus 14w. Okay, if you guys got those, either of those answers, you did a very good job. Let's move on. Alright, here we go. Example number 4. Let's do these together, please. This one says 2 times the quantity 4 plus x plus x. And so first we're going to use the distributive property to go ahead and distribute 2 inside our parentheses, okay, because we have 2 times this 4 plus x. It'd be kind of like saying we had 4 plus x once added to 4 plus x twice. 1 time, 2 times. So that is 2 times 4 plus x. So let's go ahead and do this. 2 times 4, we're going to use the distributive property. 2 times positive 4 gives us 8. And then 2 times positive x, remember we keep our sign there, is 2 times positive x is going to be positive or plus 2x. And then finally we need to make sure we add on the rest of the problem that was not using the distributive property, the dangling part there at the end, plus x. And we're almost done now. Now we just need to combine like terms. Combine like terms. Can we combine our 8 plus 2x? No way, Jose, because they do not have the same variable. They're different kinds of terms. They're not like terms. Can I combine 2x plus x all day long? All day long. Yes, we can. 2x plus x is 3x. And then we have 8 plus 3x. Final answer. On this next problem, I'm going to have you guys do it with your partner. You guys can pick partner 1 or partner 2 to do it, and the other one's going to watch, and then finally copy, 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 okay? It's a partner's choice. Partner 1 or partner 2 can do this problem, whoever wants to. And the other one's just going to watch, 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 and then finally copy, copy, copy. So I'll give you just a minute for that. Okay, let's go ahead and tackle the second part of the problem. Problem number, part B. Here we had -5 times the quantity 3y minus 6. So we're going to use the distributive property for that part, and then at the end we're going to add 7y. If we have any like terms, which we know we will, we're going to combine those at the very end. You guys should have seen that it's going to be -5 times 3y. It's -15y. -5 times -6 is positive 30. And then finally we're done with distributing. And then now we have to add our 7y plus 7y. So where are our like terms? They happen to be right here with -15y and positive 7y or plus 7y. So we have different signs happening. -15 plus 7y, -15 plus 7 is going to be -8y plus 30, and we are finished with that problem as well. Hey guys, so you can kind of see my house now. Here it is. No, we finished our lesson right now. I'm trying to get better. I got cough drops and medicine and stuff like that, so hopefully I'm getting better soon. But today's lesson we learned how to simplify expressions with like terms. That means they had the same variable, and we also learned how our different key terms worked. We learned about our constant term. We learned about what a coefficient was. Again, we already kind of knew that. And we learned how to simplify our expressions. I think we should be pretty good at that now. Our homework is going to be 5.2, 1 through 18 all. And then we're going to move on to 22 to 25 all. And of course we do spiral. Okay, have a good day, and I hope to see you guys tomorrow. Thanks.